Alright, in this video we're going to explore the 12 basic functions and a couple of their properties. So we're going to start with the identity function, and you'll notice down here the identity function is f of x equals x. The domain is going to be all real numbers, or it's going to be everything from negative infinity to infinity. The range is also all real numbers, which is negative infinity to infinity. It's continuous from negative infinity to infinity, and its symmetry is the fact that it's an odd function, so symmetric about the origin. The next two that we're going to talk about are the squaring function, so f of x equals x squared, so this is a parabola. Domain, all real numbers. Range is y is greater than or equal to 0, or if you want, we can say 0 to infinity. Continuity is everything from negative infinity to infinity, and it is an even function, so its symmetry is even. Cubic function, so f of x equals x to the third. Domain, all real numbers. Range, all real numbers. It's going to be continuous from negative infinity to infinity, and this is an odd function. So all these things for these 12 functions you are going to need to know. Reciprocal function, 1 over x. Domain is x can't be 0, so it's all real numbers except x equals 0. The range is all real numbers, y is not equal to 0, so you can see that you can't be the x or value x equals 0, because we're going to get a 0 in the denominator. And if we take that out, we can't actually hit the y value 0, right? We're going to have a horizontal asymptote at y equals 0. So continuity, we're going to say infinite discontinuity. At x equals 0. And this is an odd function, so that's its symmetry. So infinite discontinuity at x equals 0. We have that that vertical asymptote here. We have a factor that doesn't divide out in the bottom. Square root function, the domain is going to be everything from 0 to infinity, or if you want to say x is greater than or equal to 0. Range is also 0 to infinity, or y is greater than or equal to 0. It's continuous over its entire domain. Not negative infinity to infinity, because we can't go toward negative infinity, but everything on its domain is going to be continuous, and it has no symmetry. So it's not even, it's not odd. Exponential function. In this case, they're calling it f of x equals e to the x, but really it can be any number, not just e. It could be 3 to the x, 5 to the x. Domain is all real numbers. Range is y is greater than 0, or 0 to infinity. Not or equal to, just greater than. We're never going to actually be able to get to 0. Continuity, it's going to be continuous from negative infinity to infinity, and it does not have any symmetry. Natural log function. So you've probably dealt in your last class in Algebra 2 with logs. In this class and in calculus, we're going to do almost exclusively natural log, just like we're going to use almost exclusively e to the x in calculus as well. So the domain is going to be 0 to infinity, or x is greater than 0. The range is going to be all real numbers, and if you think about the relationship between exponentials and logs from last year, they are inverses of each other, so you switch the x and the y's, which means we can switch the domain and range. So domain here was all real numbers, range here is all real numbers. 0 to infinity for the range, 0 to infinity for the domain. This is going to be continuous over its entire domain. So from 0 to infinity, this thing's continuous, and it does not have any symmetry. moving right along. Two new functions. You probably haven't seen these in too much detail, but we have the sine and cosine function. So the domain of the sine function is all real numbers. The range of the cosine function is -1 to 1. It's continuous from -infinity to infinity, and it is an odd function. The cosine function has the same domain, the same range, the same continuity, but this is an even function. We're going to spend a lot of time with the sine and cosine functions. You'll notice, if you haven't seen it already, if we just shift the sine function a little bit to the left or shift the cosine function a little bit to the right, you actually have the same exact function. So we'll talk a lot about the sine and cosine functions in this class. But for now, we just need to know domain, range, continuity, and the symmetry. Next, we're going to have the absolute value function. So the domain is all real numbers. The range is 0 to infinity. Or if you want to go with this way, we can go y is greater than or equal to 0. Continuity, it's going to be continuous from -infinity to infinity, so over its entire domain. And this is an even function. Next, we have this weird thing here called the greatest integer function. It's also sometimes called the step function, and you can see here it's intx. You can also sometimes write it like this or like this. Most books are going to write it like this. What the greatest integer function is it basically rounds a number down. So if you take a number, say 1.5, plug it in, you round down and you're going to get 1 out. So 1.5 is the x value, 1 is the y value. So the domain is going to be all real numbers. The range is, we'll just say, all integers. So the z, that's a z, represents integers, just like the r is real numbers. We're not going to just say where every discontinuity here, but we'll say there's a lot of jump discontinuities. And you can see, I mean, there's going to be infinitely many jump discontinuities. And this has no symmetry. It looks like it might have symmetry about the origin, making it odd, but the open and closed circles wouldn't line up correctly if you tried to rotate this around the origin. And we have one last function, and this is one we're going to look at not a whole lot, but a little bit when we get into calculus next year, and this is the logistic function. So the domain is all real numbers. The range is 0 to 1, but it's going to be exclusive. We're never going to hit 0 or 1. It's going to be continuous over its entire domain, and it does not have any symmetry. Generally, what these are used for is talking about populations. Population growth is generally logistic, and that's how we're going to talk about it when we get into calculus next year. So that's it for the basics of these 12 functions, some of the properties that we need to know. So we'll call it quits on this video, and we'll see you in the next one.